In this video, we're going to balance redox reactions in basic conditions using the half reactions method. Balance the equation below using the half reactions method in basic conditions. So the first few steps are very similar to balancing in acidic conditions. We're going to simply separate our reactions into half reactions. It doesn't really matter which one you start with. I'm going to start with this one here, the carbon over here. So our first one would be C2, first half reaction is C2O4, 2 minus AQ, produces, I'm going to leave some room just in case I have to add electrons somewhere, produces CO2 gas. So non-oxygen atoms have to be balanced first, so we have 2 carbons here. Let's make a 2 over here to get 2 carbons. It looks like we have 4 oxygens now, so that's interesting. By doing that, we actually balanced our non-oxygen atoms, and we also balanced our oxygen atoms. So we don't have to go and add water or H's or anything like that. So we're actually done with this one, except for the charges. It's 2 minus over here. We need to make the other side 2 minus, so plus 2 electrons. That means that this is our oxidation half reaction because the electrons are being released. So this was being oxidized, likely the carbon being oxidized. If you did the oxidation numbers, you'd see that. So if this is being oxidized over here, this is the reducing agent over here. So this is our oxidation half reaction. It's balanced now. Then we're going to do the IO3 minus AQ, producing I minus AQ. And this one looks like it's already more involved just because there's no oxygen on the right side. We're going to have to start adding water. So we're going to add 3 waters over here to balance the oxygen. And then once that happens, we should check our iodine first. I didn't do that. So I is 1, so we're good. Okay, we balance the oxygens, but now we've introduced 6 hydrogens. So we have to do plus 6H plus. And now our next step is something that's going to be unique to basic conditions. You're going to add OH, the same number of OHs that you've added of H plus to both sides. So you're going to do plus 6OH minus AQ plus 6OH minus AQ. And now we're going to do something. We're going to combine these two together. So that's going to give us IO3 minus AQ. And H plus and OH is simply water, so plus 6H2O produces I minus AQ plus 3H2O plus 6OH minus AQ. And now we're going to cross things out. Since water appears on both sides, we can cancel them out. All 3 will be canceled out here, and 3 will be canceled out there to give you 3 left over. So to clean this up, we're going to have IO3 minus AQ plus 3H2O liquid produces I minus AQ plus 6OH minus AQ. And I'm just going to make this arrow a little bit smaller because I want to save some room for the electron. It's going to be on the left side. How do I know that? Well, the electron over here was on the right side, so it must be a reduction on the opposite side for this other half reaction. Because when you have an oxidation, you need to have a reduction. So it looks like everything is balanced at this point. We have 3 O's. 3 O's, that's 6 O's total. We have 6 O's here. We have 6 H's. We have 6 H's. We have 1 I. We have 1 I. Our charges, though, are they balanced? It doesn't look like it. Here we have -1. Here we have -1 and -6. That's -7. So we have to add 6 electrons over here. So now we've added 6 electrons to make both sides -7. So now what we need to do is we need to make sure that our electrons from our half reactions are equal to each other. And it doesn't look like they are. This is 2, and this is 6. So I'm going to have to multiply this entire equation here by 3. And I'm going to do that. I'm just going to put that equation down here now. So 3C2O4 2 minus AQ produces 6CO2 gas plus 6 electrons. And now I can add this up because the electrons will cancel out here. And I'll get IO3 minus AQ plus 3C2O4 2 minus AQ plus 3H2O liquid produces 6CO2 gas plus I minus AQ plus 6OH minus AQ. So now everything is accounted for. Let's go and count our total number of atoms and our charges. So we have 1I, 1I. We have 3 plus 3 times 4, that's 12. So 15 O's plus 3 more O's, that's 18 O's. Here we have 12, 6 times 2, 12 O's plus 6 O's, 18 O's as well. Here we have 3 times 2, 6 carbons. Here we have 6 carbons. And here we have 6 H's, and therefore here 6 H's. So our atoms are balanced. Now charges, we have -1 and 3 times -2, it's -6. So we have -7. Here we have -1, -6, -7. So our atoms are balanced, our charges are balanced. This reaction has now been balanced under basic conditions. So the main difference between acidic and basic conditions for the half reactions method is that you have to add the same number of OHs to both sides that you added for the H plus in order to reflect that you're in basic conditions now. And remember that you're not just adding things arbitrarily. There are OH ions present in the solution. There are H plus ions present in the solution, or rather H3O plus. And we're just trying to explain this using the ions and the substances that are present in that solution. So there are other methods of balancing. The other one's called oxidation number method, but we learned in this lesson the half reactions method. To practice, you can complete the practice problems within the lesson. The answer keys are online, so you can double check your work. Balancing redox reactions can be awkward at first, but with enough practice, they become pretty simple.